Hello and welcome you all to my new topic, that is polarography, which is an electroanalytical technique. It was guided by Anjusri ma'am and myself, Prabhash Barik. So let's start. Here is my content page, and next I comes to introduction of the polarography. Polarography is just a type of voltammetry which is used for qualitative and quantitative analysis of reducible or oxidizable substance. Next I comes to voltammetry. It gives an information about analyte by putting a graph between current and potential difference. Next, the history of polarography. It was invented in 1922 by JS chemist Jaroslav Havsky and won Nobel Prize in 1959. Next, at first we have to about what is voltammetry process. As voltammetry is used for both qualitative and quantitative analysis, so it is used in analytical chemistry also and in various industrial processes also. It consists working electrode, reference electrode, counter electrode, a battery, voltmeter, ammeter, analyte. Next, working electrode, where the oxidation reduction takes place. A voltmeter is connected with reference electrode and working electrode. The material are used in gold, silver, glossy carbon, mercury drop, etc. There are three types or many types of working electrode there: HTME, STME, DME. Next, reference electrode, whose potential difference is fixed, and we will find the working electrode of potential difference by regulating the potential difference of potential difference in voltmeter through our reference electrode. And the examples are calomel electrode, which is mercurous mercury chloride electrode, and our silver chloride electrode. Next is auxiliary electrode, through which the current circuit will complete, and a ammeter or current meter is used in working electrode and auxiliary electrode. The material are used platinum and glossy carbons. Next, the voltammetric cell solution. There are two types cell solution. Our first is our given sample, and another is supporting electrolyte. The given sample should be electroactive species, not electroinactive species, and supporting electrolyte is just a salt like KCl, KNO3, NaCl, etc. And it reduces the effect of migration of ion in diffusion process and lower the resistance of the solution as it increases the ion in the in our electrolytic solution, so it lowers the resistance of the solution. Next is characteristics of supporting electrolyte. It should be chemically inert, do not interfere with diffusion, and a high ionic conductivity, adjust pH, increase selectivity. Next is our Voltamogram is just a graph between current and applied voltage, which is from a S-shaped graph. Okay, and there is the current. So just there are three types of current, or we can say that is a residual current, diffusion current, limiting current, and there is another current is also reduced, that is migration current, where residual and migration current are there. We will neglect it, and our diffusion current we will study about it, and which the half of the diffusion current is our half of potential, which is fixed also, and we will discuss it in our polarography technique. Next, there are different types of polarography, different types of voltammetry process. There is polarography, hydrodynamic voltammetry, stripping voltammetry, cyclic voltammetry. First is our polarography. What do you mean by polarography? Polarography is a voltammetric technique where working electrode is replaced by mercury drop electrode, or TME, dropping mercury electrode, and by plotting a graph between current and potential difference. The graph arises is called our polarigram. The instrument used in polarography is our polarograph, and the technique is known as polarography. These are the common terms which you have to remember. Next is our instrumentation. In our instrumentation of polarography, it consists a reservoir of mercury, where mercury will flow and the dropping mercury electrode, which is a working electrode. Calomel electrode is a reference electrode, auxiliary electrode or counter electrode. Inlet of nitrogen gas, where oxygen will expel out, and glass capillary electrolyte, supporting electrolyte, voltmeter, ammeter. Next, principle of polarography. Principle of polarography is the study of electroactive compound which should be electrically active, and the principle is that gradually increasing voltage between our working electrode and reference electrode, that is DME and SCE, or simple columnar electrode, and dropping mercury electrode. Current flows between dropping mercury electrode and auxiliary electrode. Mercury continuously dropped from our reservoir through capillary tube, and the optimum interval should be 2 to 5 seconds. And here our cathode is our indicator electrode or our working electrode, and the anode is taking here as a reference electrode or simple columnar electrode. And the data results from our automatic recording instrument, where polarogram will result, and the trace is called polarographic wave. Next is our working electrode. Working electrode is our in our working section there are two types of electrode we use, that is polarized electrode and non-polarized electrode. As there is the use of polarized electrode, so the voltammetry process is known as polarographic technique. And what do you mean polarized electrode? Polarized electrode, the electrode potential varies with the flow of small current through the electrode. That's called polarized electrode. We can easily also say that polarized electrode is equal to working electrode is equal to indicator electrode. That is our dropping mercury electrode. Next is our non-polarized electrode. In our non-polarized there is no current changes, or the no electrode potential will change with even of flow of current, and our non-polarized electrode is equal to reference electrode, which is our simple columnar electrode. Next you can see the picture here. So there is the beaker where our analyte and supporting electrode is present. Let's take here KCl is our supporting electrode, which is taken to 30 to 100 times as compared to analyte, and the nitrogen inlet is there for removing the oxygen, and gradually increasing voltage applied through the polarographic cell, and current is recorded. Okay, as we have to make the graph between current and potential difference, which is our polarogram, so we have to take this, and graph is plotted against our voltage applied and current, and at last the diffusion current produced in our polarographic cell, it is proportional with our concentration of the analyte. You can see in the figure that the nitrogen inlet gas is there, and here is our reference electrode. Our working electrode is our dropping mercury electrode, and the auxiliary electrode is our platinum auxiliary electrode, and the mercury drop will fall from the mercury reservoir through the capillary tube drop by drop, and you can see the pool of mercury is there, and all the things are connected with our voltmeter and ammeter, and it was regulated through a potential stat, and we will make a polarogram, which our graph through our voltmeter and ammeter values. Next I comes to dropping mercury electrode. What is dropping mercury electrode? The first section where mercury reservoir, capillary tubes, platinum wire, all these things are there. Is our dropping mercury electrode. Okay, typically dropping mercury electrode consists of 10 cm of fine capillary tubing, and the diameter should be maintained so that the time between each drop is 2 to 5 seconds occurs, and the diameter of the drop should be 0.5 to 1.0 mm, and is highly reproducible, and the fresh reproducible surface is important because the current measure are very sensitive to cleanliness and freedom from the disturbance. Okay, so you can see the picture. There is a dropping mercury reservoir, and the mercury will fall through the capillary tube, and the another electrode is there, that is platinum electrode, and you can see the drop of the mercury. Next I comes to rotating platinum electrode. You can see the in our dropping mercury electrode, there is a platinum wire or platinum electrode. It is in rotating condition. Okay, as it is not used in our more voltage application, so there is a platinum electrode is used in our rotating condition. Why it is in a rotating condition? Because if it is in stationary state, then diffusion current will slow. Okay, and it will make disturbance with our falling of dropping mercury drop. So there is a constant speed should be maintained, or constant, or platinum electrode should rotate with a constant speed for increasing the for maintaining the ID current or diffusion current, and attain should steady diffusion current. For attaining steady diffusion current, the platinum electrode should be rotated, and the electrode is constructed from standard mercury seal, and it consists about 5 platinum wire of 0.5 diameter. You can see at the last of the mercury drop, the 5 platinum wire is extended, and 0.5 its diameter is 0.5 and it rotates with a constant speed, that is 600 rpm. Next is your Polarography. You can see that the Polarography is the graph between current and applied potential versus a simple column electrode, and you can see when there is the current arises, that is residual current, and after that, after some time, there is a diffusion current, and after some time there is a limiting current. Okay, when there is no flow of current arises with increasing voltage, there is the residual current arises, and migration current also arises, which we will not take into consideration. And after some time, when there is the flow of ion occurs towards the dropping mercury drop, and there is the formation of high amount of current, that is our diffusion current. Okay, and after some time the current is limited, which is a limiting current arises, and the middle part of the limiting current is our I average, and our total is our limiting current, and the AB is there. It is used for to separate electrolyte. Okay, next is our current. In our Polarography, there is three types, or we can say four types of current, as the residual and migration current are not taken into consideration, so I neglect the migration current. So first is our residual current. It may be arises due to impurity or due to electrical double layer, which is our Faradic and non-Faradic current may produce, and we will not take it into consideration, because there is no current. This current will not affect our solution. And next is our diffusion current, which is our main part of the analysis, and it produces due to oxidation or reduction of the analyte. And let's say our metal reduced metal plus reduced to metal, and it combined with our mercury forms amalgam, and ID is directly proportional to concentration. We will discuss in our there is the equation, that is Ilkov equation, which gives our quantitative analysis. And in our diffusion current, there is the current, it processes a long gap between our residual current and limiting current. And limiting current, after diffusion current, the current is limited, and limited amount of ion will get contact with our dropping mercury drop, and for which the current is limited and parallel with our voltage or potential difference. Next I comes to factor affecting diffusion current. The diffusion current is dependent upon the concentration, temperature, viscosity of the medium, capillary characteristics, lifetime of mercury. As concentration of the ion increases, the diffusion current also increases. It is directly proportional with it. And temperature, there is a constant temperature should be maintained. If temperature increases, the dropping mercury time interval will decrease, and the repeating fall of mercury drop arises. So diffusion current will also vary. So there is a constant temperature should be maintained for it. Viscosity of the medium, viscosity increases, and diffusion current also decreases. It is inversely proportional with it. And next is our Polarography maxima. in our limiting current is a parallel with our potential difference, but sometimes there is the abnormal increase occur in our limiting current, so it may be caused due to our catalytic discharge if a flow of mercury is too high, and low concentration of support due to low concentration of supporting electron maybe arises the polarography maxima, and it can be removed through by using a surfactant, that is titanium X100, resin, gelatin, etc. And why we take mercury in our polarography technique? Because it is a liquid metals, and it shows a wide range of negative potential, and it can regenerate the new drops easily, and many metals can be reversibly reduced into it. Next is our examples of mercury electrode. That is, there are three types of mercury electrode: hanging mercury drop electrode, dropping mercury electrode, static mercury drop electrode. And the advantage is it is a high speed process or a high speed analysis process. It is used for organic and inorganic sample. It can perform qualitative and quantitative analysis, and the reduced metal at the electrode surface can form amalgam. Next, I will limit our disadvantage. If we care about it, we can easily practice our polarography technique. And the disadvantage or the limitation are: mercury is poisonous and volatile, and it is not useful for performing oxidation, because the polarography is designed such for reduction process. And electrode cannot be used over plus 0.4 volt, because mercury dissolves, and not lesser than minus 1.8 volt, because hydrogen is got liberated. And the capillary is difficult to maintain, because the rust particle can block the capillary. Next is our application of polarography. There are two types of applications, and what is our qualitative and quantitative analysis. In qualitative analysis, there is a measurement of half-wave potential through our diffusion current. Okay, because in diffusion current there is the formation of oxidation reduction occurs. So when half of the ion get converted into cation or anion, that half time or half of the current is called our half-wave potential. Okay, so the half-wave potential of metals or organic compound are fixed. So by looking at polarigram, we can easily find out which substance is present with it. So this is our qualitative analysis. Through qualitative analysis, we can detect the metal ions. You can see cadmium 2 plus has a half-wave potential minus 0.64 volt, and cobalt 2 plus is minus 1.20 volt, etc. there. Next, we can easily find out if there are two or more metals present, because it shows 2 or 3 half-wave potential, and we can easily match with our the standard half-wave potential. Next, we can also easily find out the detection of organic compound, because the half-wave potentials are fixed of many organic compounds, metals, etc. And we can also use it in detection of trace element of electroactive substance also. Next is our qualitative quantitative analysis. For the analysis of quantitative, we can use there is a equation, that is Ilkovic equation, where diffusion current is equal to 607 and C d to the half m to the power 2 by 3 t to the 1 by 6. Okay, where d is the diffusion coefficient, c is the concentration, and is the number of electrons used in oxidation and reduction, m is our mass of the mercury drop, and t is our lifetime of mercury drop. Okay, so if we take all these constant by keeping concentration, and it will form the diffusion current is directly proportional to our concentration. So we can easily find out by taking 2 or more sample solution. So we can find the concentration of unknown substance through with respect to another concentration of another electrolyte. So there is the methods. First method is unknown concentration cation can be find out through a uh, standard solution. Okay, if there is a standard solution, then there is a formula C unknown is equal to ID unknown by ID standard into C standard. Okay, you can see in the graph that is first is our standard, first is for our standard, and second is for our unknown sample solution. Okay, next the method is for unknown concentration of cation. Okay, it also can be find through the calibration curve appears. Okay, if we know the metal through qualitative analysis, then we will take more solution with different beakers, and we will result through polarography technique 6 curve arises, and when we will make calibration curve through diffusion current and concentration, there is a straight line arises, because these are directly proportional. So by looking this straight line, our unknown concentration of the metal we can find by looking its diffusion current through our polarography or polarigram. Next comes to, we can also find out the simultaneous determination of cation from the mixture. If we take a alloy or something, then we can find qualitatively which ion is present in there, and by taking their calibration curve we can find out which metal is present. Next, the third application is the determination of dissolved oxygen. As oxygen hydrogen peroxide appears in the polarific cell at minus 0.05 volt, so we can find whether the oxygen is present or not, and after some time minus 0.9 at 0.9 volt, the hydrogen peroxide get converted into water, and this type of process is basically used in the study of respiration of green algae and photosynthesis also. Next, pharmaceutical application. Basically we use for detection of metals or organic compounds. So in this process, the pharmaceutical application use also polarography technique for dissolved oxygen and peroxide, trace metal and metal containing drugs, antiseptic and insecticides, vitamins, hormones, antibiotics, alkaloids, pharmaceutical substance, blood serum, and cancer diagnosis also. So here is my presentation, and thank you all. Have a great day.